right, everyone, I'm going to go ahead and get started. Thank you all for joining me today. My name's Jonathan LeBlanc. I head up global developer advocacy for PayPal and Braintree. And I apologize for any sneezes, sniffles, or anything like that. Apparently, every single time I give any talk on Bluetooth Low Energy or beacons or working with them, I get sick. So I attribute that to the beacon curse. So the curse of the beacon tends to follow me around quite often. Now remember that if any of you are giving talks, that curse tends to come with all the speakers that I know. So what we're going to be talking about a little bit today is working with beacon technology and building mobile location-aware systems on top of mobile with it. How many of you here have worked with beacons before? Okay, a couple of you. That's good, because I'm going to go through a lot of the problems that you're going to run into when you're working with beacons, a lot of the things that you should be thinking about that you might not necessarily be doing. So we'll look through some code examples on implementing it on mobile. We'll take a step-by-step approach as we're going through there. So even if you don't have any prior experience, this will give you a good overview on all the good and bad bits of working with beacons. I've been working with them for off and on several years. Proprietary beacons before open specifications like iBeacon or AltBeacon came into play. So usually when companies had built out some Bluetooth low energy technology for location awareness, they would build out a proprietary solution. The open hardware was there, right? So you would have Arduinos, you would have Bluetooth low energy shields, you would have all the technology that you needed to build out these projects in the first place. So a lot of people built them out in a proprietary way. So we'll be looking at that and looking at some of the open specifications that are out there, some of the different beacons that are being utilized today that you can start working with. So for those of you who aren't familiar with beacon, the first obvious question is, what is the purpose of it in the first place? Well, think of it in this way. We're all familiar with social check-in technology. You broadcast out to the location that you're actually in. This is both like that and completely different than that, because that's just about saying, hey, I'm here. There's no sense of, are you actually still there? Where are you in that space? Have you left that space? Any of that information. It's just broadcasting out a location that you're actually physically in at some point or physically near. Everything around beaconing technology is physical presence, being location aware of where you are in that physical space. So as I'm walking around a store, the beacons are basically generating out what's called an advertisement. Whenever they generate out some information on who's around me, what's around me, to get proximity detection, that's called an advertisement. So beacons like these little estimates over here would be broadcasting out that location. And that's everything that a beacon is built off of, is creating a location-aware system so that while you're moving through a physical space, you can tie it into some online medium. So let's say I'm going through a storefront and I have no idea what's in the aisle in front of me. I could have a beacon in that aisle, and that beacon can be broadcasting out, hey, this is the location that you're in, so let's send you out some information on what's in the aisle in front of you. So that's been extended through accessibility. It's been extended through shopping. So there's a whole bunch of different ways that this has been integrated over the years. But realistically, it's all built off the same spec. So the Bluetooth spec, we're all very familiar with Bluetooth. I'm not even going to ask you guys how many of you are familiar with it, because it's become ingrained in all the technology we use, a lot of the technology we use, and how we do things day to day. The Bluetooth specification overall is just about maintaining this continuous connection as you're rolling through. And when we're looking at the differences between Bluetooth and Bluetooth low energy, and if I haven't mentioned it, Bluetooth low energy is what powers these beacons. So it's a different variation on the spec. As of Bluetooth version 4.0, Bluetooth low energy was introduced. It's also referred to as Bluetooth Smart as a marketing term, but I always refer to it as Bluetooth low energy or Bluetooth LE. That's how the vast majority of the people who are developing on the products will refer to it. So that's how we're going to talk about it. Now, Bluetooth overall is just about opening up a a continuous connection between two devices. So you would connect, let's say, your phone to your car, your phone to a wireless boombox, stream out some sort of media like audio. It can be used to stream video captions from a phone to a TV or anywhere else. It's really about sending rich media through a continuous open connection. It also eats the crap out of your battery. So you either have a consistent battery source that's plugged in, or your battery just drains like crazy. Bluetooth Smart or Bluetooth Low Energy is all about the complete opposite. We want to know where you are in a physical location, but we don't want to eat the battery. So basically, it's just going to send out these small packets of information as opposed to rich media. It's sending out small little bits of data, just enough for you to know where where you are in proximity to the beacon and any other information that it wants to send through. But you're going to get small little packets coming through as opposed to rich media. That's the main difference between the two. Now, if we actually look at how it works point to point as we're running through, you'll always have to start with a centralized device. Now, how many of you here know if your phone supports Bluetooth Low Energy? Okay, a lot of you. And how many of you here have some smartphone after, let's say, iPhone version 4 or Android, I'd say after the last couple of years? Okay, a lot of you. Now, everyone that has some sort of modern smartphone, most likely you're going to have Bluetooth Low Energy technology built into the smartphone. Most devices nowadays will support both Bluetooth and Bluetooth Low Energy. It's kind of a either or and most of the time the actual component for supporting Bluetooth Low Energy is so ridiculously cheap that it's integrated into a lot of the technology. So that's why all of our technology nowadays tends to be perfectly in line for working with beacons, because everyone carries a cell phone around with them. I remember giving talks on really working with underserved communities in the payment industry, and some of the research that I saw was that there are more cell phones in people's hands than there are toilets. Toilets that they use. It's ridiculous numbers. And there are more active cell phone connections in the world than there actually are people. So we're building off a standard that people are using day to day, is what I'm saying. So we start with our centralized device. This could easily be a smartwatch that might have some sort of BLE component in it. A lot of the smartwatches now are either like this, the Moto 360, that might pair with a device that might not have it, or you might have some smarter devices. Samsung's releasing quite a number around their Gear series, around standalone watches. And the standalone watches are the ones that you would want to look at for components integrated. So you might see them in smartwatches to begin with. And they pair directly with the beacon hardware. So let's say I'm walking in front of a beacon, and then it's broadcasting out at certain intervals, so whatever intervals I might set it to, or whatever intervals the beacon itself is set to advertise at default. And then it would communicate directly with the phone. The phone would send a notification if the notification settings are set, and allow you through an application to work directly with the beacon. So that's how it tends to pair. It tends to work as a push mechanism. So it'll push out to the phone on a regular basis. It's been modified many different ways throughout different beacon technology, proprietary or open, to work with this as both a transmitter and receiver, and using it in multiple different ways. So that's where this extra piece comes into play. You can actually start utilizing this in a more extensive way, or working with beacon technology in a more extensive way, to not only be a push mechanism to say, this is where I am in the physical space, but you can also use it as a mechanism for feeding back data from an endpoint. So a certain API that you might want to pull data from. For instance, I'm working with this one startup now who is utilizing Estimote beacons in a storefront. So what they're doing is, in a pop-up shop, they'll put these by, let's say, a shirt rack. Stick it up there, and then this beacon will in turn communicate with the phone and send you back information on how popular those shirt buying experiences are, how popular the material is, and will allow you to pay for it directly in the aisle. That's the type of functionality that I'm talking about when you're actually extending upon a beacon as a location check-in. It's a little bit of workaround on that one, but there are a whole bunch of use cases around this. Let me give you a real-world use case where some of these have been implemented directly on doing that. In addition to the SMO beacons here, I have this experimental little device, which is a PayPal beacon. This was an early iteration or an early prototype, which is why it's so ugly as sin. But really the components underneath here would be a small microcontroller, a Bluetooth low energy shield, maybe Wi-Fi on top of that, depending on the communication. The way it's supposed to work is to allow you to, let's say you don't have a cell phone connection, you can't get to your carrier, you can't get to Wi-Fi, but you can still connect to these devices, to these beacon devices. So the beacon device works as an actual bridge for communicating with PayPal APIs. So in real-world implementation, I'd walk up to a pop-up shop that might have one of these things plugged into a USB port. It's not running off it can run off an external battery source, but it can also run off a USB connection, which some of them do. And it'll wake up the PayPal application and say, would you like to check in to the storefront? And I could say no, and nothing gets sent to PayPal, nothing gets sent to the merchant themselves. Or I can say yes, and what happens is a set of encrypted packets are sent through the beacon device, communicated up through the PayPal APIs. So everything's completely encrypted as check-in. PayPal in turn will use the check-in API to decode that message and then check the person in, send back the message that they've checked in. Now meanwhile, once that transmission is all done, the beacon goes back to sleep to save on energy. But at the exact same time that the communication is going back saying that the check-in happened, the merchant's getting a notification saying this is the face, this is the name, this is the ability to check out with the PayPal accounts for that person who's now in your store. You walk through the store, pick out the items you want, go up to their tablet or their kiosk, wherever they have their point of sale, and you say, I want to check out with PayPal. It checks you out right there through your PayPal account. Now this is an example that I'm showcasing to you because it's a real physical world example of utilizing these things to extend beyond just location awareness into tying in API data. And that's exactly what it is. It's tying in payment data, all encrypted, and on the PayPal application, for instance, the way that it's decrypted is there's a public key baked into the application, the PayPal application, which decrypts the message and allows you to communicate back with PayPal APIs. So that's one proprietary approach to this technology. It was released a couple months before the technology overall. It was tested and integrated within some startups, some merchants, a couple months before the iBeacon specification had come out. So this is one piece of utilization of Bluetooth Low Energy. But when you're really looking at it, one of the big questions that I always get with beacons is, well, since I know where the location is, if I have someone walking in front of my shop, can't I send them advertisements to say, hey, come into my shop, I have a deal for you? Or they're walking through the shop and I can keep sending them deal after deal. Isn't that a great idea? It's a freaking horrible idea. And that's exactly how you get notifications turned off, get your application deleted from someone's phone. So when the piece of advice, the biggest piece of advice that I ever give anyone on dealing with identity, dealing with physical location when you're notifying someone, the single piece of information that you should always keep in mind is don't be creepy. And you know what? There's a lot of people out there who will want to build systems that do advertisements like that. Beacon technology should not be utilized like that because it's really going to creep people out, to be honest, and it's going to make them uninstall your application. It's going to make them not want to work with you. This should be utilized to extend the functionality of a person in a physical space, to extend upon what they're already doing. For instance, a couple of years ago, we have this hackathon series at PayPal Braintree, global hackathon series called Battle Hack. And we run it in 14 or so locations throughout the world. So we had our winners from the first year. They were a team from Russia. And what they had built out was essentially a piece of beacon technology. Over the 24-hour period, they built it with a Arduino, a Bluetooth Low Energy shield, but it was for micro donations towards mobile blood banks or mobile health care or things like that. So that's what they had built out in the implementation. So this technology can be extended into accessibility needs. The same team, when they won their city, had built out something called Connected City, I believe it was called. And what it was for was to help the blind as they're walking through the city. You would put beacons around on specific sites, specific buildings, and then it would send cues to the phone to trigger audio cues to tell them exactly where they are, what they're doing, what's around them. So it allows far more functionality around physical spaces. So there's a lot you can do with it, but don't be creepy. One of the things that we should really look at as we're looking at Bluetooth is this is a few of the specifications on Bluetooth Low Energy as you're using it, and it's vastly different than that of traditional Bluetooth. So you have an intermittent connection, and that's a really important aspect of the battery savings. So Bluetooth will have that continuous connection, but this is all about you send your packet, you shut down. It maintains that connection with the smartphone so that it can send messages back and forth, but it's all about high battery usage. That's why a lot of them say that they last about 1.5 years. I wrote "ha" beside that because that's mostly a lie. Realistically, on regular usage off of regular range, regular advertisement, not in best case scenario, you would get 7-8 months off of those tests if I had it deployed continuously. Now, I use these things typically at conferences to deploy in things like scavenger hunt games or demos. So when I use them, they would last for several years, because when I'm not using them, I use the dashboard. They come with a little dashboard, a configuration dashboard. So I tune down the advertisements, how often it advertises, and I tune down the range to about 1 meter, 1.5 meters. So the thing lasts probably 65, 70 months. So tuned down completely when not in use allows you to save on the battery life, but realistically, regular usage, 7-8 months. Off the nicer ones. Range realistically is about 75 meters at top. Some advertise that they could push to 100. When you push, the higher the range that you push to, the more battery you're going to use. So if you push to 75 to 100 meters, you're going to drain that battery like crazy. And realistically, in most implementations, you don't need that. You can deploy multiple different beacons throughout a physical space, and it would actually make it a better scenario for a deployment. But you can tune these things down to about 1 meter as far as the broadcast range. So the higher the range that you get to, the more potential physical barriers you would reach. We'll talk about a little bit about going through physical barriers and how that affects these beacons, because dealing with the signal and dealing with the proximity is some of the trickiest bits here. Everything I'm going to be going through is both on the development on top of these as well as the deployment. It's kind of a weird mix where it takes your maker skills and it takes your development skills, because you tend to play with both. And the biggest part about this is not working with the SDK. It's not working with the technology overall. It's about manipulating it in a physical space where these are and controlling the space that you deploy them in and how to work with that. So the vast majority of the beacons that are deployed that you're going to actually see now are based off the iBeacon specification. There is another alternate specification that was created. So you have Apple's iBeacon specification that they released. That's the vast majority of the beacons that are deployed now that you can buy. That's what a lot of them are based off of. And also, I'll be giving a link to these slides at the end for you to download in case you need links, anything, because I'll have a lot through here. But there's also another technology called, or another open SDK called AltBeacon, which we'll get into in a little bit. But that was created by, I believe it was Radiant Network. And they released an alternate specification to not just work with iBeacons, but any beacon. So there's those ones out there, but iBeacon is going to be the one specification that we're going to work off completely. And definitely the one that we'll be looking at right here. Oop. Looks like, here. Give me 1 second. Okay, perfect. So the beacons the one thing that we should be looking at right now is the beacons that you'll actually see deployed in the wild, the ones that you would tend to see on a day-to-day basis. These are both my favorites, as well as the ones that I've seen the most of. You know, depending on the country, depending on the location, this might change. There might be different ones that are used. But by far and large, almost every deployment I tend to see utilizes or is solely run by Estimote beacons. These things are 33 bucks a piece. They come in a little pack of 3 like this. And they look very aesthetically pleasing, like little silicon rocks. They have a little sticky bit on the back for you to stick on walls. Great little piece of technology. So the one thing when you're actually looking at these, you know, the price tag is pretty hefty for them, but if you're using them in a deployment, they're not too bad. The battery life is good on them. They have a nice dashboard for you to manipulate the advertisement interval, how often they broadcast, and the proximity range. So they also have two other sensors in there, temperature and motion. Good in theory. Temperature sensor is behind this little silicon shell. So when I was actually testing it this morning, it ran around 5 degrees centigrade higher than the ambient temperature in the hotel room. Oh, and get used to Celsius and meters, by the way, when working with beacon technology, because that's what everything's in when you're working with a lot of these sensors. So the temperature sensor tends to be a little bit higher because it's behind this nice little shell. Then let's talk about motion. Motion, great in theory, right? Try to get proximity detection when you're actually something in motion as you're walking around. It's hard enough when it's in a physical space like this, trying to triangulate a user's location down to a couple meters. Now, take that into motion, and then getting a proximity that, you know, how far you are away from a person in motion, it's not going to happen. So you're going to get a vast range. Where that comes into play and becomes good is when actually just needing to be somewhere around that actual location. So, you know, the motion aspect, good in theory, you just have to figure out where to practice it. Temperature, you know, good and bad, you just have to adjust for the temperature fluctuations. There's another one that our team in Australia tends to work with is the Blue Cat beacons. You know, the last time I was working with them, they're currently in a trial. So you can put in a request as a developer to get a series of 3 beacons. Their price point is probably going to be somewhere in the $75 to $99 range, just like the other ones. But the concept that I really like about them is that they run off AA batteries as opposed to a 3-volt coin battery cell. And also that the batteries are much easier to replace. So when I was first working at these things, I was thinking, how do you replace the battery in the Estimotes? Well, the same question was asked to a couple of the representatives over there, and what they said is you have to use some of your maker skills to pry open the little silicon shell to get the little chips out, the little board out, and realistically, it's going to trash the beacon if you do that. So, you know, the board works perfectly fine without the shell. You don't need it. If you're deploying inside, it actually might work a little bit better that way because you don't have the shell to block some of the signal. And I'll go into some of those blockages in a minute. But there is that. Then there's the gimbal tag, very low price range. From the people I've talked to that actually use the tag, they don't have a dashboard to be able to attune the proximity and the power usage, generally, the advertisement. So they're very easy to deploy. You just toss them around wherever you want, no fear of losing them, and then they'll broadcast out. So those ones are, you know, a good starter one if you're looking for something cheap and accessible. So the gimbal tags are great. And then the Contact IO, they have a little bit less of a price range, and they still are on par aesthetically as well as capabilities-wise with the Blue Cat and the Estimote beacon, you know, as far as their usage, but they advertise a higher battery life than any of the other beacons that are out there. I think it was around 1.5 years. give or take. Again, just like with battery usage, it really depends on your application and how you deploy it outwards. So when we're talking about the beacon advertisement, when a beacon, you know, every so often, it might be 100 milliseconds, it might be every 2 seconds. When it advertises out, what does it send? Well, there's a couple of pieces of information that it's going to send out at bare minimum through the, based on the iBeacon specification. The unique identifier, which is a 16-byte string that will differentiate large groups. Usually within the estimates, they're all just unique on their own, unique strings. And then there's 2 pieces, the major and the minor, each 2 bytes themselves. And those 3 combined make up a 20-byte string that's a unique identifier for each beacon. So that's how you identify each beacon in a physical space. The best way of thinking about the major and the minor is, let's say they're deployed at a department store. You have 3 deployed in the shoe department, 3 deployed in the women's clothing department. The major would be, you know, 3 of those beacons in the shoe department would be 0, 3 in the clothing department, 1, and then the minor, each beacon underneath that major would be 0, 1, 2, then 0, 1, 2. So you differentiate them like that. You can differentiate them however you want on a major and minor to make up a unique identifier. But the biggest question usually comes with working with these beacons is, how do you deal with battery life versus range? And this is going to be a constant topic that you're going to be looking at as you're working with beacons. It's always a trade-off. The best way of looking at it is, depending on what your deployment is, how you're deploying it, how many beacons you're deploying, and we'll talk about deploying at scale because it tends to get a little tricky. And there's a couple of things that you can do around that. But you always have to give up either battery life or range. It's kind of one or the other. So when you're looking at it, you really need to look at the physical space that you're in, how large the proximity around the beacon that you want someone to be able to detect the beacon. So it's as much about where in the physical location it is and how far away you want the person to be able to pick it up. And that's really how you set it. So, but that's actually why I like the dashboards on some of the ones like the Blue Cat beacons or the Estimote beacons, because I can change all that depending on my usage. And I don't run into problems with mass deployments and signal degradation, signal interference, or anything like that. But I had mentioned battery replacements on the Estimotes. I had seen this great article when I was looking into battery replacements and how they're actually replaced. And this picture was awesome because it showed exactly what you need to do to replace a battery on an Estimote beacon. It's the exact same thing I'm going to do as soon as these batteries die. I'm going to rip open the shell just like he's done. He's cut the shell, the silicon shell, and inside one of those is the actual beacon. That's the functionality behind the entire beacon, what it is, and it's running off of one of those 3-volt cells. So that can be replaced. You don't have to have the silicon shell on there. The only reason it's there is for to prevent it from being affected by elements, to allow you to deploy externally, to put it on a wall, or anything like that. Now, let me show you exactly how, the steps that you would have to take to go through building out your own beacon and actually working with the technology, because it's not that complicated. It's only a couple of pieces of hardware that you're actually going to need to work with. So here's your component list. Depending on the type of beacon that you're working with, you're definitely going to need some sort of microcontroller. Like an Arduino, you can use on Adafruit, there's these tiny little boards that I've been playing with recently. They're probably maybe about like that big, really, really small. So you have one of those with a little breadboard, and you have a little Bluetooth low energy shield on top of that, and that's your functionality. That's the base level hardware that you need to actually build it out. Now, if you want something a little bit more complicated, like these PayPal beacons, where you're actually broadcasting out to a Wi-Fi signal. Let's say there's no Wi-Fi connection on the user's phone. Then a Wi-Fi shield, you stack that on top of the Bluetooth low energy shield on top of the microcontroller, and then you have Wi-Fi capabilities on top of that to connect outwards to an API endpoint. Then you can attach a whole bunch of sensors, whatever you would need. So mimicking the Estimote, you would have an accelerometer that would measure motion. You can have a temperature sensor on top of there. And then if you want to do any detection, alternate detection of people, so if you can't get a good range in a physical location, let's say there's too many barriers in the way, too many physical barriers, then you can do something like a human sensor to be able to detect actual motion. So there's a whole bunch of options. Besides the hardware though, the biggest thing that you're going to have to think about is signal interference and signal degradation. Those are two massive aspects towards beacon development that are critical when deploying. So the big difference is signal interference will have, alternate signals that are going on around it. It might be a whole bunch of beacons being deployed at the exact same time. When you actually deploy all these things at the same time, or when there's interference, it won't pick up all the signals. So when I was testing out a scavenger hunt game, which we'll go through the mechanics of in a bit, I was deploying maybe 6 of these. So I was seeing if I could pick them all up, and I had them in close proximity range. They were all overlapping each other, and they would sometimes they would send me 5 back, sometimes 4, sometimes 6. So it would definitely the signal would interfere with each other if they were in close proximity. So then there's also signal degradation, which will cause just a difference in the actual proximity range when you're actually working through the when you're actually looking at the signal that's coming through the proximity to the beacon. It will send you a skewed result. It'll send you a result that's not as confident in the range, so it might be a couple of meters off your actual physical location. Now, these are some of the things that cause signal interference when you're actually deploying in a physical space. There's a lot of them. So things like microwave ovens, if you're deploying in an actual kitchen. You have direct satellite service, external electronic sources. Down there you have external monitors and LCD. These things all affect the range. But one thing you might notice as a trend here are electronics that work in that 2.5 gigahertz to 5 gigahertz range. It's because the beacons are running at the 2.4 gigahertz range. So that's why those signals tend to cause problems. So you would have wireless devices. You would have any other physical devices that are running in those particular ranges. Those would cause signal issues. Give me 1 second, I'll bring this back up. Almost there. No. Huh. Okay. Well, as we're going, let's talk through this one a little bit. So the other issue that you're going to run into is signal degradation. So the signal degradation issues that you're going to run into have to do with physical properties of things that the signal has to go through. So how many of you have seen that animated GIF of a Wi-Fi signal filtering through a house? Have any of you seen that? As it goes through room to room, crosses through drywall, things like that? No? Okay. Well, it's showing you that physical barriers such as plaster, physical barriers, thank you, Justin, such as walls, such as furniture, all cause potential issues with the signal as you're running through. Thanks, guys. So the interference levels that you're going to run into range from very, very low to very high. So on the low end, you would have things like wood furniture as you're going through, synthetic material, which is kind of like these shells, and then single pane glass. So just regular glass that you would see internally or on the external, an external house. So these are ones that you don't really have to worry about too much. Then and those will probably cost maybe half a meter of range if you're actually going through them. Now on the medium interference, let's say 1 to 1.5 to 2 meter range, you would be running into things like water, bricks, and marble. The one that you should really pay attention to here is water, because one of the biggest issues between beacon communication is actually dealing with people in a room. And what are people mostly made up of? Water. Yeah. So going through people actually causes signal degradation. So that'll cost you a couple of meters. On the high end are things like plaster, concrete, bulletproof glass, and very high interference is metal. So you're going through metal and you're good luck trying to get any sort of proximity off that. Higher interference, you're getting maybe 5 meters of cost range on that one. One of the things that caused me some issues with this, and this is actually when you're deploying in physical locations, something that you really need to think of is also where you're deploying it. So I live just a little bit north of Miami, and I've always grown up north, grew up in Montreal, and I'm used to wood frame housing construction. Now, when I'm down there, we had our house built, and I was shocked that it was all metal frame construction. And then, based on regulations, we had to either have hurricane shutters or hurricane windows. We went with the hurricane windows, which are these things here. You could take a small handgun to it, and it wouldn't break in. So it's really thick. When I was actually deploying these in a room and trying to get it in an alternate room, I was going through things like the bulletproof glass and the metal frame construction, which was causing me an insane level of signal degradation. Also, when you're looking at large buildings, large infrastructures that you're actually going through, apartment buildings or high rises, it's all concrete and steel. So deploying in locations like that, you would need a beacon in almost every single room, because going through those walls will just kill it, just kill the signal completely. So some of the considerations besides signal that you're really going to have to look at are things like this trilateration algorithm. It's the same thing as triangulation. So one of the ways that you can actually increase the accuracy of beacons is deploying multiples at, in a physical location, and then getting an average range between the 3 beacons, or 3 or more beacons, and then you can find an approximate range. It's usually within a meter or 2, a meter if you're lucky, most likely 2, that you can actually find someone in. But the complexities behind building something like this is all based off of a trilateration algorithm. It's something that most of the SDKs out there that are offered within beacons already have built in. So the first link there actually shows out the math behind a trilateration algorithm on triangulating the location of someone in a physical space. Now, being the lazy developer I am, I looked for someone who had already employed that, which is link number 2. Good old Stack Overflow pays off again. We have the build out of a trilateration algorithm that can be deployed within a mobile environment. So those 2 links are really great for actually building out that if you want to build out a physical beacon yourself. Another thing that you have to be aware of is how Bluetooth, that radio signal, switches bands. So let's say it runs off a specific band and is sending out a signal. If it gets interference, it's going to try switching bands and trying to get a better signal out there. So that'll give you a more accurate result. The unfortunate part is band switching costs time, and since it's pretty much measured by power and time to get to the actual mobile device, then the proximity range isn't as confident. So when I'm saying not confident, it means within several meters or within a half a meter or what have you. The confidence range is what we're talking about. Then if you want to build out a complex algorithm to not just to broadcast out a beacon location, then you have to deal with things like secure and external communications. So if we're sending users' personal information through, if we're sending check-in aspects, if we're sending payment details, then you need to send completely encrypted packets through. So utilizing the beacon as almost a bridge towards an API endpoint and sending all those encrypted, utilizing a public key or something, some encryption mechanism towards the mobile device as well as the API endpoint. All right. So let's go ahead and get started with that and take a look at how we're actually deploying this on a mobile device. So the first thing that we're going to have to consider is whether to use a SDK that's built for the beacon itself or use something that works for all of them. So In our North American team, our European team, we typically will work with estimates or we'll work with some other beacon, just one beacon on our deployments. So we tend to work directly with the SDK because it has functionality for dealing with a lot of the sensors that are built into the estimate and working directly with it. And that's really why we're targeting those SDKs. But we have my colleague Jeff over here from Brazil. He works with a number of different beacons. He has a session at the end of tomorrow, and he's going to show you a lot about actually building out a candy machine with a whole bunch of just open hardware, including beacons. But he works with a lot of beacons, so using this alt beacon specification or the alt beacon SDK becomes more viable because he's dealing with multiple different variations, and you just really have to set up each individual beacon if you're not working with the alt beacon spec. So if this will work with alt beacons, it'll work with iBeacons, it'll work with any beacon that's out there. So there's different options depending on what you're working with. I tend to work with those open SDKs. First thing when you're working with an Android emulator that you're going to probably run into, it's the first thing that I ran into, is that Bluetooth LE is not available on the emulator. I was thinking that at first I was doing something wrong. There was a setting, there was something in the manifest file that I had to include that I wasn't. There was just something missing because every time I tried to enable BLE, it would send back an error where I would spit out this to the page. It turns out that the Android emulator is not by default going to set up a BLE connection, a Bluetooth Low Energy connection. So you have two options. I tend to run all of my samples off of physical devices, so I have a Nexus 4 and a Nexus 6 that I run off all the samples. And you can do that as long as the device is BLE enabled, so you can use that to test all your applications. Or you can actually get the emulator working and take the more streamlined approach, which is actually emulating BLE on the emulator itself. So thankfully, we go back to more articles from devs who have already built this out. And realistically, all you really need is a virtual machine software like VirtualBox. Most of them build off of VirtualBox. And then a BLE USB adapter that you would plug into the computer. And this is the blog article that covered the entire integration step by step as you're going through. It could do it much more justice than I would ever do. So that is the implementation on actually getting it to work within the emulator so that you don't get those errors. And if you don't have a physical device, it's the best way of doing it. All right. So let's get going on the beacon scavenger hunt and taking a look at what this is going to look like. So how it's actually going to work is this is our deployment at specific conferences. So we have a lot of room to play with. This is one of the things that we like to do, just as a fun little game. We will deploy, let's say, 6 beacons all over the place. They'll be sticking on a wall, they'll be sticking underneath a escalator or what have you. The user would walk around with the application, this scavenger hunt application, and then when they come into the physical sphere of the beacon, it would register, hey, you're in close proximity to a beacon. Would you like to try to find this beacon and actually unlock it? So it would start giving a distance feedback system. Now, the one thing about beacons, as they just broadcast outwards in proximity, you don't have direction. So how many of you, when you were kids, used to play that, you blindfold and then you go warmer, warmer, colder, colder, trying to find something, right? Same principle. So as we have proximity, we're basically sending out advertisements, let's say every half second, and the advertisements will come out, and if the distance is closer than it was before, it would say warmer, warmer, hot, boiling, all that, and if you're working away, it would say cold, freezing, etc. So that's the feedback system that we would get visually. When you actually unlocked a beacon, we set it within a 3-meter range because we deploy at conferences where we don't control the physical space. So there's a ton of people, there's a ton of devices, lots of interference. So we want to make it as easy as possible for people to work with. So we set it to a 3-meter range where if you come within proximity of the beacon, it shows that beacon as locked, as found, and it gives you a visual badge. Once you unlock all the badges, it flags a hunt completion, which unlocks a last beacon, which would be most likely deployed on myself or my colleague Justin over here. So we would use ourselves as physical motion beacons. And then it gives you a wide range of proximity around the person, and then you just go find them to get some prize or something like that. It's our scavenger hunt game. So that's exactly what I'm going to show you right now, and working with the code base behind deploying the beacons just like that. So let's go and hook this puppy up. So the first thing that we're going to look at is adjusting the beacon settings. Instead of doing this through slides, I'm actually going to load it up on the beacon demo. I'm going to load up this little projector here. We can all see that, right? So this is the Estimode application when you're actually in the physical location of a beacon. It gives you things like little demos, proximity demos, and things like that. But what we're looking at down here is beacons. So what it's doing right now is scanning all the beacons in range. And all my beacons are right here. So it's picking them up. And as you can see, since they're all in the same proximity, they are going to show at different ranges because that's how it works. Because it's not going to get the complete proximity behind it, but it's going to get near. But what we're really looking at is when we go to list item. So we actually list them off, and let me see if I can get this a little clearer for you. It's a little bit off. There we go. But what it's actually showing is each of the beacons that is registered towards me, that's in the physical space. Since I'm signed in to Estimate here in the mobile application, as well as I have all my Estimates logged in towards my account, so they're all registered for my account, they're going to show up here and authenticate themselves as me in the space. So when it's authenticating myself within that, it'll give me options down here, besides showing information on the beacons, of modifying the broadcasting power, the advertising interval. So if I do broadcasting power, that's going to allow me to set the range, the proximity range. Within the scavenger hunt demo, I would want to set something around a 30-meter range. I could set that up. Right now it's 7, 15, 30. So I can set up a 30-meter range and change it like that. As you can see, it gives you feedback on the estimated lifetime of the battery based on the beacon. So that's actually one of the nice pieces as well. So if I go back, and now I go down to my advertising interval, since we want to do this on a regular interval, so every every, let's say, 100 milliseconds or something like that, we can just bring it all the way down so that it's broadcasting at a regular range. And as you can see, look at the remaining battery life, 4 months off of that on regular usage. And if I drag it all the way to the end to 2 seconds, is 63 months. So huge range on advertising out these data. So that's something that you really have to look at as you're deploying your beacons. So that is how you actually control the beacons and start working with them within the Estimode application. So that's how you're going to switch your range and your power. Now, when we go into our Android application, the first thing that we're going to need to do is enable a couple of things in the manifest file. First two user permissions that you're going to see are the Bluetooth permissions. That's going to be this thing is cursed, I apologize. The first two things that you're going to see are the Bluetooth connections. Here. Of course. Let's get this working. Give me 1 second. Almost. So the first two ones that you're going to enable are the Bluetooth connections, and the second one is going to be the actual beacon service. 1 second. Justin, can I borrow you for a second? Set this up while I run through it with them. Thank you. So those two pieces of information, you're going to set up a service, which is going to be the actual SDK, the Estimode SDK. And that's going to be when you actually download the SDK, put it into your library, and allow it to link towards on your manifest file. Then you're actually going to just have those two Bluetooth elements to be able to enable both Bluetooth and Bluetooth Low Energy. And if you give me 1 minute, we'll see if we can grab this one. So while we're waiting, how many of you here work on hardware projects on a regular basis, implementation of beacon technology? Do you work with hardware at all? Any microcontroller work? Arduinos? No, a couple of you. A little bit. Yeah. So a lot of the skill set on here is working with the working with little maker skills. I'm going to drag this all the way in so that it doesn't fall, and I'm going to stop walking by it. Thank you. Okay, we're back. But it is a lot of the maker skills, and as you're seeing right now, it says you have a little bit of development. It's really just SDK integration, but a lot of it is on breaking out your maker skills a little bit. So the next thing that you're going to do is set up a beacon manager, and this is using the Estimode SDK. So the beacon manager is going to be your overarching class, your parent class on working with all the beacons. It's going to allow you to set up all your listeners. It's going to allow you to set up all your beacons. It's going to allow you to set up everything that you need. In the case of our demo, what we're just showcasing right now for brevity is actually just setting up one beacon. So we're going to set up the user identifier for a single beacon at the top. Then we're going to set up a particular region, which is enabling that beacon within physical space. So allow it to be able to be attuned towards the beacon manager, so the beacon manager can keep an eye on that one. So that's going to set up your Estimode beacon, and then you just create a new beacon manager. So that's the first step. Now you have your beacon manager set up to be able to do anything that you want, to be able to attune towards that beacon and start working with it. The next thing you set up is actually using a listener. So the way it's going to work is your Android application that you're running, and I know I have an iPhone here, but if you're working with Android device, it's going to just set up a listener within the application to listen for beacons that are in the neighborhood or in the particular range. So the listener, all you do is set up a new ranging listener, and within the iBeacon specification, ranging is the action of trying to get the proximity of a beacon. Then we're just going to set up that that individual implementation, and then you have all the ability in there to be able to listen towards the beacons that have actually been found in the physical space, which we'll get into in a second. At the end, when you're done actually working with the beacons, you want to shut down your application, you can go ahead and just stop ranging, which is going to stop proximity detection and stop the listener. All right. So when you actually find a beacon from this listener, when you actually find a beacon in that space, through Estimode, it's not only just going to contain that power and the user identifier, it's going to contain a couple of other methods that you can pull off of. So based off an object, it's just going to have a couple of methods that you can pull. So your unique identifier, your major, your minor, your measured power, everything that we've gone through already. But then it's going to go through your, it's going to give the MAC address of the actual hardware. It's going to give you the receive signal strength, and as well as a friendly name. So whatever you set that friendly name to within Estimode. Now, the internals of that method that we just took a look at, the ranging listener, look kind of like this. So when you're actually working with the beacons, you can, what we're just doing is setting up a high distance in that, because that's going to be our starting point when we come into proximity of the beacon, which would be set to, let's say, through 30 meters. Then we can loop through all beacons that were found. So any beacons that are physically present towards the device, then we can start running through them. Within the Estimode SDK, they have a set of utility methods that you can start pulling out. One of them happens to be compute accuracy. Compute accuracy is going to give you the approximate proximity, or the proposed proximity that the beacon's pulling off of, based off of any signal interference and signal degradation. It'll give you the most likely distance that you are from the beacon. So it's going to pull that back, and we'll get that as the current distance. If the current distance is lower than the previous distance, it's going to send back a visual feedback mechanism saying warmer. If it's further, then it's going to send back colder. If it has already discovered the beacon, it's going to ignore it. So that's really what this code base is doing, and where our triggers would end up being if we're sending back visual elements. All the visual elements are stripped because we're just dealing with the beacon code here. And realistically, that's the beacon code. It's working with an SDK within a physical space, so there's not really too much to it when it comes down to the code base. The code base is one little piece of working with a beacon, but it's actually understanding the beacon hardware, how Bluetooth Low Energy extends. That is really the complexity here, where to deploy it in a physical space. So the last thing I'm going to go through is just actually playing with the physical location of beacons and how to deploy them if you're working with a series of different beacon setups. So first off, the vast majority of the deployments that you'll get to, as well as this beacon demo, have to do with working with a single beacon. So single beacon can work as long as it's in a very controlled space. In vast majority of the deployments, that's perfectly fine, because you can get within a couple of meters, and that's registering yourself as within the physical space of a beacon. And one of the biggest things that you have to watch out for is that you're not going to get 100% accuracy. So when I was running through the Estimate application, running into this demo of a proximity demo, all three of these beacons were sitting physically on top of the phone at the time. So they had no barriers. There's nothing that would cause signal degradation in the space that I was using at them. And you can see that they're showing them at different locations. They're all physically on there. So that's what you're going to have to deal with. And this ranging listener, that inner circle is about 0.5 meters. The outwards ones, I believe, is 1.5 or 2 meters. So there is a much difference in the range when you're actually pulling that. The further the range away that you actually get, the more potential signal degradation, the less likely it is to pull a physical location. So when we're actually deploying these single beacons within a scavenger hunt or within any sort of implementation where you need to use this approximate physical location, we usually pull immediate proximity of the beacon, so where you're actually physically present, to about 2 to 3 meters. So that's about the range that you'd want to deploy in an uncontrolled environment. Now, there are ways of improving the accuracy. It does get a little tricky, though. A lot of the SDKs that are out there currently, they implement that triangulation algorithm that I was talking about. But the way that it's going to work is you'll take these beacons and you'll deploy them at like a higher location or at different heights and such, where they can give you a proximity. It gives you a variable proximity on the beacon. But you're going to want to know how far these beacons are away from each other. So let's say I deploy one every 5 meters and start ranging out from that and pulling off utilizing these 3 different signals to pull in a user's physical location. So what I'm going to do is triangulate the user's location based off of an average proximity. So I can say from beacon 1 it's 2 meters, beacon 3 it's 3 meters, etc., etc. And then we can triangulate exactly where the user is within about a meter or 2 meters. So triangulation algorithm is actually really good for when you're in uncontrolled environments, so like this. And just make sure when you're actually deploying them, you deploy them high enough and away from people so that they actually have a clear view or clear signal to the device that they're actually going to be used with. So a mobile device. So don't deploy them on the ground, because they will have to go through furniture and lots of people and lots of signal interference. So the other thing is actually deploying them at scale. So when we're deploying these things at scale, we have some major issues, and that's with the signal interference of the beacons themselves. Let me give you an example of one of the implementations that I was talking through with some other folks that were implementing these at kind of a mass scale. They had a museum, and they wanted to push a beacon off of every piece of art, sculpture within the physical location, within a room. So let's say you have 50 pieces of artwork, each with a beacon deployed directly underneath them. Then you're going to get a whole bunch of different signals coming through. And how do you determine where these actual pieces of art are and where the person is in conjunction with it? Because all these signals are overlapping, it just creates a giant mess. And most likely, as you've seen before, it's if you have, let's say, 5 or 6 beacons, it might not pick up all the same ones at the same time. Best possible thing you can do in a scenario like this currently, with a lot of the implementations that are out there, is tuning down the range of the beacon. So let's say you have a piece of art right there, another one right there. You tune it down to about 2 meters, 1.5 meters, and you get the user physically there in the space by the time it triggers off that notification to start pulling in some information about that piece of art. Even if you get multiple signals that are around, you'll only get maybe 2 within that actual physical location, so that you can adjust for that and try to figure out which one it is, or give them the option to see all 3. So what you're going to want to do is adjust the signal intensity so that you actually bring it down towards the user's direct range. So the last thing that I'm going to talk about is just about beacons in the deployment. As you've seen, the beacon SDKs, alt beacon is the exact same way. In the actual implementation, it's no different than implementing any other SDK out there. If you're working with building your own beacon, the hardware is simplified as well. It's working with just with a microcontroller with a Bluetooth Low Energy shield, maybe a Wi-Fi shield on top of that. You're working with very basic hardware, hardware that's incredibly cheap too. And that's exactly why a lot of these beacon companies have taken off. We have a lot of beacons being developed on top of the iBeacon specification. We don't have all that many that are extending beyond that into proprietary implementations, but the ones that are being attuned towards direct needs, such as the PayPal beacon for physical shopping. So when you're actually building out one of these, you want to build something that's for the actual deployment that you need it for building out something that extends beyond the base level functionality that you're going to work with an iBeacon. There's tons of iBeacons that are out there that are just doing the exact same thing, which is just push notifications, to give you an approximate location. So integrating different sensors, integrating different features, integrating the ability to work with APIs, different services. This is really where a lot of this technology is moving towards. Creating things like in-aisle shopping, creating extensibility towards a person's physical location is all that this is about. So that's the most important thing that I can see with beacons, and as they're being extended in the future. It truly is kind of a wild west of hardware right now with these types of beacons, because there's both good and bad, and a lot of this is understanding the hardware, understanding the physical locations as much as it is programming out the beacon and building it within a mobile environment. So that's the most important steps within building out these beacons, is exactly that. So thank you very much, everyone, for joining me today. Here's the link towards the slides, and I do appreciate all of your attention today. And I think open for questions. All right. Yes?
Can you talk a little bit about the sticker beacons?
Oh, the sticker beacon. Yeah, so talk a little bit about the sticker beacons. Estimote is releasing a new series of what they're calling sticker beacons. I'm going to try not to switch off of this. They look like these, but they're pretty well flat. What they're going to be utilized for is being actually deployed within, like on the bottom of shoes, or in kind of mobile environments. They're going to try to do the exact same things as what these beacons are, but they're not released yet. The price point is going to be $99 for 10, I do believe. But that's essentially what they're going to be doing, is creating a beacon in a very small scope. And as you saw within those beacons inside, the board itself is very small, so you can get it down to that sticker size. And since we have a lot of technology around wearable computers that have just like a sticker on top of here with a couple of little sensors, very easy to do. So you can get these things down as really almost razor thin on there. Yes?
Two questions. First of all, do you know if the battery life affects the range configured on the device as it ages?
So if the range affects the battery life? Sorry?
If the age of the device and how long it's been operating affects the range?
If the battery has been sitting around for and degrading for that long, yes, it would affect if the battery integrity is compromised, yes, it would affect the range and the power and really anything else around that. But almost every single beacon that I've seen, they come preloaded, so they basically come advertising. So they'll drain the battery automatically when they start coming to you. So you usually don't get to the situation where the battery is sitting there for that long.
What about the age of the hardware?
Sorry, who? Oh yeah, age of the hardware.
The age of the hardware.
Yeah, so that would definitely affect it if the board itself is not pulling in a good amount of power. It's going to affect the range, it's going to affect the proximity, because it's not going to be able to send out the same signal. So most likely what's going to happen, if that's the case, is that the range that it's sending out at is not going to be as large as what you set it to.
Yeah. If all of these various devices are conforming to the same standard, how does the whatever you call the software,
the alt beacon,
the software you use to configure it, how does it know which of the devices it sees are that brand?
Okay, so let me see if I can actually, if I still have this loaded up. I don't. So there's actually an implementation that shows exactly this. Let me see if I can bring this up. No, I can't. Okay. Well, basically when you're working with an alt beacon, if you're working with alt beacons, it's really easy to set up, just like you would see here. If you're working with any other beacon, you basically give it the string of identifiers, range, and things like that, just some pieces of data that it needs, and then it can find the power range on the beacon and pull it from there. So you basically just send it this ranging string to be able to determine what the beacon is. That's how it works with any sort of Bluetooth device. So I have some code samples. I think in the deck I actually have a link towards those code samples that showcases how an alt beacon would work with the same string. Any other questions? All right. Well, anyone else that wants to chat, I'll be around here for the rest of the day. Thank you.